Hello everyone, thank you very much for watching this video. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, do you want a cookie? Start class? Very good. Welcome to SAT ACT Prep. This is quick drill set B to solving with substitution and solving conceptually. So as we've been talking about in the previous sessions, there are predictive outcomes when multiplying even odd combinations as well as positive negative combinations, just as there are predictive outcomes when we add or subtract. So we're going to go through two tables that show those outcomes that you can rely upon, and then go through some multi-statement questions that's going to test those concepts. So let me share my screen with you. And if you have any questions, then please drop a comment below. The resource document here is going to be available on Certified Learning Center's website. Just make sure that you're looking at the document that has the reference number 1001-8. That'll make sure that you're at the right place. So as I said at the beginning, there are some predictive outcomes when adding, subtracting, multiplying, or dividing combinations of even and odd values. So when we add or subtract, an even plus or minus an even will give you an even. An even plus or minus an odd will give you an odd. An odd plus or minus an even will give you an odd result. And an odd plus or minus an odd will give you an even result. Similarly, with multiplication and division, when we have even-odd combinations, the products have predictive outcomes. So even times an even will be an even times an odd will be an odd times an even will be an even, and only an odd times another odd will ever be odd. And that also goes for division when you're talking about whole numbers, of course. The reason being that it has to be a whole number in order for it to be even or odd. The definition of even is that it's a multiple of 2. The definition of odd are all integer values or whole values other than even values or non-multiples of 2. So we're talking about whole values in here, so it gets a little bit gray, a little bit hazy with division, but we're talking about division of whole numbers. So let's go right into some examples. I would recommend that you pause the video and attempt the question yourself and then unpause it to watch the recording, watch the solution rather. So question number 1 asks, if m and n are positive prime integers greater than 2 and q is an even integer, which of the following statements is or are true? Statement 1, the quantity m plus n times the quantity 2 plus m plus n is an odd integer. Statement 2 says the quantity 3 times n plus m quantity squared plus the quantity 3 plus 2n quantity squared is an odd integer. Statement 3 says the quantity 5 plus q plus m minus the quantity 3 times m plus n quantity cubed is an even integer. So take a few moments and solve that problem, please. So if we wanted to solve with substitution, we'd want to first identify the domain or the acceptable values that we could use for each of these variables. They say that m and n are positive prime integers greater than 2. That's just a tricky way of saying that they have to be odd, because if they're prime integers greater than 2, 2 is the only even prime integer, because all other multiples of 2 are necessarily divisible by 2 and therefore not prime. So if it's going to be prime and greater than 2, then it has to be odd. And then they flat out tell us that q is an even integer. So we're just talking about odd and even values. So to pick easy to work with numbers, maybe m would be 3, n would be 5, and q would be 2. So you could sub in and evaluate, but let's think about these conceptually because usually it's a little bit quicker. So m plus n, that's going to be an odd plus an odd, times 2, which is even, plus m, which is odd, plus n, which is odd. So an odd plus an odd will be an even. An even plus an odd will be odd. That odd plus another odd is going to be even. An even times an even will always produce an even product. So statement 1 is false. Statement 2, 3 times n, so that's going to be an odd, which 3 is odd, n is also odd, plus m, which is odd, quantity squared, plus 3, which is odd, plus 2, which is even, times n, which is odd, quantity squared. An odd times an odd, we're going to do the multiplication first. So we're going to do an odd times an odd and then the even times an odd here. So an odd times an odd is going to be odd. So we're going to have an odd plus an odd quantity squared. Just going to bring that odd down for now. An even times an odd is going to be even, quantity squared. An odd plus an odd will be even. An odd plus an even will be odd. Now an even squared will stay even. An odd squared will stay odd, because that's the same thing as an even times an even, and then an odd times an odd. An even plus an odd will be odd. So statement 2 is true. In statement 3, we have 5, which is odd, plus q, which is even, plus m, which is odd, minus 3, which is odd, times m, which is odd, plus n, which is odd, quantity cubed. So an odd plus an even is going to be odd. That odd plus another odd is going to be even, so this whole thing is going to turn even on the left. An odd times an odd is odd. An odd plus an odd is even. So that's going to be an even cubed. An even cubed is even, so this is going to be an even minus an even, which will result in an even difference. So your answer here is going to be statements 2 and 3 only, which is answer selection C. Question number 2 asks, if m and n are positive prime integers greater than 2, and q is an even integer, which of the following statements is or are true? Statement 1 says the quantity m plus n minus q, quantity plus the quantity 2 plus n plus q is an odd integer. Statement 2 says the quantity q squared plus m squared, quantity times the quantity 2 plus q plus n, quantity squared, is an odd integer. And statement 3 says the quantity 5 plus m plus q times the quantity 4 minus m minus n, quantity cubed, is an odd integer. So take a few moments and solve that problem, please. So again, the domain didn't change here, so we could still use 3 for m, 5 for n, and 2 for q if you wanted to use substitution. Thinking about this conceptually, however, we're going to have m plus n, so we're going to have an odd plus an odd minus an even, quantity plus an even plus an odd plus an even. So on the left, we have an odd plus an odd, that's going to be even. An even minus an even will be even. An even plus an odd is odd. An odd plus an even is odd. And then, so this simplifies to just an even plus an odd, which will always be odd. So statement 1 is true. Statement 2, we have q squared, so that's going to be an even times an even, plus m squared, that's an odd times an odd, times 2, which is even, plus q, which is even, plus n, which is odd, quantity squared. So an even times an even will be even. An odd times an odd will be odd. An even plus an even will be even. That even result plus an odd will be odd. So that's going to simplify into an odd squared. An odd squared is odd. So this is going to be an even plus an odd times an odd. An even plus an odd is odd, so this is going to turn into an odd times an odd. An odd times an odd will be an odd product. So statement 2 is true. And statement 3, we have 5, which is odd, plus m, which is odd, plus q, which is even, quantity times 4, which is even, minus m, which is odd, minus n, which is also odd, quantity cubed. Okay, an odd plus an odd will be even. An even plus an even will be even. So this whole thing turns even. An even minus an odd is odd. An odd minus an odd is even. So that's going to be an even cubed. An even cubed will be even because it's just 3 evens times each other. An even times an even will be even. So statement 3 is false. So your answer here is going to be A. Statements 1 and 2 only. Question number 3 asks, if m and n are positive prime integers greater than 2 and q is an even integer, which of the following statements is or are true? Statement 1 says the quantity q times n times m, quantity cubed, times the quantity 5 times q times n, quantity squared, is an even integer. Statement 2 says the quantity 3 plus m times the quantity 2 plus q, quantity squared, plus the quantity 6 times n, quantity squared, is an even integer. And statement 3 says the quantity 5 times m times q, quantity squared, times the quantity 3 plus m plus n, quantity cubed, is an even integer. So take a few moments and solve that problem. So the domain has not changed for m, n, and q, so we could still use m as 3, n as 5, q as 2. But solving conceptually here, we're going to have q times m times n. So we're going to have an even times an odd, quantity cubed, times 5, which is an odd, times q, which is even, times n, which is odd, quantity squared. An even times an odd is even. An even times an odd again is still even, so that's going to be an even cubed. An odd times an even is even. That even times an odd is still even, so that's going to be an even squared. An even cubed is even. An even squared is even. An even times an even number will be an even product. So statement 1 is true. Statement 2, 3 is odd, so we're going to have an odd plus m, which is odd, times the quantity 2, which is even, plus q, which is even, quantity squared, plus 6, which is even, times n, which is odd, quantity squared. An odd plus an odd will be even. An even plus an even will be even. An even times an odd will be even. An even squared is even, so I'm just going to bring this first even down, but the second even squared will just be an even result. And the same thing here, this is just going to be an even result because an even number squared is even. An even times an even is even. And an even plus an even is even. So statement 2 is true. And lastly, we have statement number 3. So 5 is odd, times m is odd, times q is even, quantity squared, times 3 is odd, plus m is odd, plus n is odd, quantity cubed. So an odd times an odd will be odd. That odd result times an even will be even. An odd plus an odd will be even. That even plus another odd will be odd. So this is going to be an odd cubed. An even squared, or an even times an even, will be even. An odd cubed, that's going to be an odd times an odd times an odd. So an odd times an odd times an odd will be odd. An even times an odd will be even. So statement 3 is also true, so our answer here is going to be D, statements 1, 2, and 3. Question 4 asks, if m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1 says the quantity m times n times q, quantity raised to the 5th power, times the quantity 2 times m times q, quantity cubed, is a negative integer. Statement 2 says the quantity 3 times n times q, quantity raised to the 7th power, divided by negative times the quantity 5 times n times m, quantity squared, is a negative integer. And statement 3 says the quantity negative 2 times m times n, quantity squared, times the quantity negative 3 times m times n times q, quantity raised to the 7th power, is a negative integer. Take a few moments, please, and answer that question. So you can see here that we've completely changed the domain of m, n, and q. So now we're talking about m and n being negative numbers and q being a positive number. So maybe m could be negative 1, n could be negative 2, and q could be positive 1 if you were subbing in here. But let's go ahead and think about this conceptually. So we're testing negative versus positive. So I'm not concerned about even versus odd. I'm thinking about negative versus positive now. So m and n are negative, q is positive. So for m times n times q, I'm going to have a negative times a positive, quantity raised to the 5th power, times 2, which is positive, and that's all I'm concerned about. So 2, which is positive, times m, which is negative, times q, which is positive, quantity cubed. Now you need to know when you exponentiate to an odd number, like to the 5th power or to the 3rd power, if the value is negative, it's going to retain that negativity. So if you exponentiate, or if you raise to an even power, the negativity goes away. But if you raise to an odd power, like 3, 5, 7, 9, 11, 13, so on and so forth, any odd exponentiation is going to remain negative. So here we're going to have a negative times a negative, which is positive. That positive result times a positive will be positive. So we're going to have a positive number raised to the 5th power times a positive times a negative. That's going to be negative. That negative result times a positive will be negative. So that's going to be a negative cubed. A positive number raised to the 5th power is going to be a positive number. A negative number raised to the 3rd power, that's an odd exponentiation, so that's going to remain negative. A positive times a negative will be a negative product. So statement 1 is true. Statement 2, we have 3, which is positive, times n, which is negative, times q, which is positive, quantity raised to the 7th power, divided by, and you can almost think about that as that negative sign as a negative 1. So I'm going to literally put a negative outside of the parentheses. And then we have a positive 5, we have a negative n, and we have a negative m, and that's quantity squared. A positive times a positive, there's only one negative value. There's an odd number of negative values in that product string, so it's going to be negative. So we're going to have a negative number raised to the 7th power, divided by the negative I'm going to keep on the outside and just evaluate inside first. A positive times a negative, the two negatives cancel out, and that's going to be a positive squared. A negative raised to the 7th power, that's an odd power, so that's going to remain negative. and then I'm going to have a negative times a positive squared. A positive squared is positive, but a negative times a positive is negative. So I'm going to have a negative divided by a negative, which is going to be a positive quotient. So statement 2 is false. And statement 3, we have negative 2, which is obviously negative, times m, which is negative, times n, which is negative, quantity squared, times negative 3, which is negative, times m, which is negative, times n, which is negative, times q, which is positive. Quantity raised to the 7th power. So a negative times a negative times a negative. There's an odd number of negatives there, so that's going to remain negative. That's going to be a negative squared. A negative times a negative times a negative, that's an odd number of negatives, so that's also going to remain negative. That negative result times a positive is still negative, so that's going to be a negative raised to the 7th power. But notice we have a negative number squared. On the left, we have a negative number raised to an even power, so that's going to turn positive. On the right, we have a negative number raised to an odd power, so that's going to remain negative. A positive times a negative is going to be a negative product. So statement 3 is true. So our answer here is going to be answer selection B, statements 1 and 3 only. Question number 5 asks, if m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1, the quantity m times q times n, quantity cubed, times negative 1 times the quantity 3 times m times q, quantity squared, is a negative integer. Statement 2, the quantity 3 times m times n, quantity squared, divided by the quantity 5 times n times q times m, quantity cubed, is a positive integer. In statement 3, the quantity negative 2 times n times q, quantity squared, times the quantity negative 3 times m times n times q, quantity cubed, is a negative integer. Take a few moments, please, and solve that problem. So the domain for m, n, and q is the same as in 4. So we're just talking about negative numbers for m and n. So maybe m is negative 1, n is negative 2. And a positive number for q, so maybe q is positive 1. But thinking about this conceptually, 1, we're going to have m times q times n. So we're talking about negative versus positive here. So we're going to have a negative times a positive times a negative, quantity cubed, times a negative on the outside of the parentheses, times 3 is positive, m is negative, q is positive, quantity squared. A negative times a negative is going to be positive. There's an even number of negatives, so they cancel out, so that's going to be a positive cubed. I'm going to keep that negative on the outside and evaluate within the parentheses first. So within the parentheses, a positive times a negative times a positive. There's only one negative. There's an odd number of negatives, so that's going to remain negative, and that's going to be a negative squared. A positive cubed is going to be positive. A negative squared is going to be positive, because that's an even exponent. A negative times a positive is negative, so this is a positive times a negative, which will be a negative product. So statement 1 is true. Statement 2, we have 3, which is positive, times m, which is negative, times n, which is negative, quantity squared, divided by 5, which is positive, times n, which is negative, times q, which is positive, times m, which is negative, quantity cubed. A positive times a negative is going to be positive. That's going to be a positive squared. A positive times a negative times a positive times a negative. There are two negatives involved there, so they're going to cancel out, and that's going to turn positive. Oops, excuse me, that's a positive number to the 3rd power. A positive number squared is positive. A positive number cubed is positive. A positive divided by a positive will be a positive quotient. So statement 2 is true. And we have statement number 3. So negative 2 is a negative number times n, which is a negative number, times q, which is a positive number, quantity squared, times negative 3, which is a negative number, times m, which is negative, times n, which is negative, times q, which is positive, quantity cubed. A negative times a positive, there's two negatives in there that will cancel, so that's going to be a positive. So it's going to be a positive squared, times, we have a negative times a negative times a negative times a positive. There are three negatives there. There are an odd number of negatives, so that's going to be a negative product. That's going to be a negative number cubed. A positive number squared is positive. A negative number cubed, however, is going to remain negative. A positive times a negative will be negative. So statement 3 is also true, and our answer is going to be D, statements 1, 2, and 3. Oops, excuse me. I'm sorry, my camera's hiding that. And the last problem here, number 6. If m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1 says the quantity m times q quantity squared times negative 1 times the quantity m times n quantity cubed is a negative integer. Statement 2 says negative 1 times the quantity negative 3 times m times n quantity cubed divided by the quantity negative 1 times the quantity negative 5 times q times m quantity squared is a negative integer. And statement 3, we have the quantity 2 times n times q, quantity raised to the 8th power, times the quantity negative 3 times n times q, quantity raised to the 6th power is a negative integer. So please take a few moments and solve that problem. So just as with 4 and 5, the domain is the same. So m, we could use negative 1. For n, we could use negative 2. And for q, we could still use positive 1. Solving conceptually, however, m is negative, so this is going to be a negative. Q is positive, so it's going to be a negative times a positive quantity squared times a negative times a negative times a negative quantity cubed. A negative times a positive is a negative, so this is going to be a negative squared times, I'm going to carry down that negative on the outside. A negative times a negative is positive, so it's going to be a positive cubed. A negative squared is positive because it's an even exponent. And then a positive cubed is positive. But a negative times a positive is still negative. So this is going to simplify to a positive times a negative, which has to be a negative product. So statement 1 is true. Statement 2, we have a negative times negative 3 times m times n quantity cubed divided by negative 1 times negative 5 times q times m quantity squared. So evaluating within the parentheses, on the left we have a negative times a negative times a negative. We have an odd number of negatives, so I'm going to carry this outside negative down, but on the inside we have an odd number of negatives, so that's going to remain negative. So that's going to be a negative cubed. I'm going to carry this negative on the outside down. On the inside of that second parentheses on the right, we have a negative times a positive times a negative. Here we have an even number of negative values, so that's going to eliminate and become positive. So we have a positive squared. On the left, we have a negative raised to the 3rd power. Remember, if we exponentiate to an odd power, that's going to remain negative. So that's going to be a negative times a negative divided by a negative times a positive squared is positive. Now a negative times a negative is going to be positive. A negative times a positive is going to be negative. And a positive divided by a negative is negative. So statement 2 is true. And lastly, let's look at statement number 3. So we have 2 times n times q. So 2 is positive. So we have a positive times a negative times a positive, quantity raised to the 8th power, times negative 3, which is negative, times n, which is negative, times q, which is positive, quantity raised to the 6th power. Within the parentheses on the left, we have a positive times a negative times a positive. That's an odd number of negatives. So on the left, that's going to remain negative. So we're going to have a negative number raised to the 8th power. On the right, we're going to have a negative times a positive. That's 2 negatives, so that's going to eliminate and simplify into a positive product. So that's going to be a negative number raised to the 8th power times a positive number raised to the 6th power. But when we exponentiate to an even value, remember that these are going to turn positive. So ultimately, this is going to be a positive number times a positive number. That has to be a positive product. So statement 3 is false, and our answer here is going to be answer selection A, which is statements 1 and 2 only. If you have any questions on anything that we've done today, then please let me know either in the comments below, or I can always be contacted on my social media accounts. Thank you guys very much for watching. I appreciate it very much. If you find these videos helpful, then please like and subscribe and share with your friends. But otherwise, Dr. Tot, do you want to say goodbye? Dr. Tot, you want to say goodbye to everybody? Come on. Come on, you guys say bye. You say bye? Come on. Very good. Can you say bye? You sit? Say bye. Say bye. Come on. You can do it. Bye. Come on. Oh, really? You're really that tired? Okay. Dr. Dot has given up today. Thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all soon.